Hi class, this is Dr. Jones. I'm going to show you how to do the graph and the calculation for this experiment, which is on Newton's second law of motion. Some of you told me that the previous video I did was very useful, so I'm going to try to do this again. Now, for my data, my empty cart was 80 grams. Now, the system mass is going to be the mass of the cart and whatever is in it, and the hanging mass. So in this case, it should actually be 85. So I'm going to type in 85. This would be 200 plus the 80 for the cart plus the 5, which is 285. This is 200 plus the 80 for the cart plus 10, which is 290. And this is 200 plus the 80 for the cart plus 20, which is 300. Okay, so those are my three system masses. Now the average time, I'm going to use my average function like I used in the previous video. And so to do that, what I'm going to do is I am going to do the @ symbol, type in average, open parentheses, highlight all 3 times, close parentheses, and enter. So that gives me the average time. Then, of course, to fill it in with all of the data values, I click in the corner and it should become a black plus. And if I hold that, left click it and drag it down, then what it does is it copies that formula into all of those cells, which is great. Okay. Now I'm ready to calculate the acceleration. So to calculate the acceleration, what I have to do is use the equation that I have in the procedure. So I click equal because I'm doing a calculation, and it says 2 times the distance, which I believe was 40 centimeters, divided by the average time, and I'm going to square it. So I'm going to do a shift 6, which is the caret key, and then a 2, and that gives me the square value. And again, I click here, I go to the corner so it becomes a black plus. I left click and hold it down, and I drag it down. So now I have all of the accelerations. Now what I'm going to use here in the second table is the values where I had the masses added, and I have 3 of those, and I have 3 sets here. And the first thing it says is the system mass in kilograms. So to calculate that, what I need to do is divide grams by 1,000. So I'm going to click here and put an equal sign because I'm doing a calculation. I'm going to click on the first mass with 200 grams and divide that by 1,000. Okay. And that gives me the cart mass with 200 grams in kilograms. Again, click in the cell. When it becomes a black plus, I left click, hold it down, drag it, and it didn't quite drag far enough, and it does all of the calculations for me. And so I'm going to add a decimal place here. So if I click on increase decimal, it adds a decimal here. I'm going to add 2 decimal places there. Okay. Now I'm ready to convert the acceleration into meters per second squared. So to do that, to convert from centimeters to meters, I divide by 100. So I'm going to put an equal because I'm doing a calculation. I'm going to click on the acceleration and centimeters per second squared, and I'm going to divide that by 100. Okay. So that is my acceleration. I click on the cell. I get the black plus. I left click, drag it all the way down, and it does the calculations for me. Next, I have to convert the hanging mass, the mass hanging, to kilograms. Again, to do that, I divide by 1,000. So I do an equal sign. I click on the first one that I have, okay, and I divide it by 1,000. I hit enter, and then I go black plus, Drag it all the way down. Okay. I'm going to add a decimal place here and add a decimal place there. Now I'm ready to convert it into weight, and you've learned from the textbook to convert it into the weight force. You multiply it by 9.8, so I'm going to put equal. I click on the hanging mass. I do times 9.8. Okay? So again, I click here. There's my plus. I drag it down. Okay, and now I have my weight forces. So now I'm actually ready to start graphing. Okay. So to graph, remember on the horizontal axis, we usually put what we're given, and on the vertical axis we put what we measure. So in this case, we're given the weight force that was hanging, and we measured the distance so that we could calculate our acceleration. So that's what we're going to do. So what I'm going to do is I'm going to put here, okay, that I'm going to put weight force in newtons, okay, and here I'm going to put acceleration and meters per second squared. And remember, I put a 2, then I highlight the 2, I go to font, and I make it a superscript. Okay. Now, I'm just going to copy and paste my values that I have here. So I'm going to highlight these 3 values. I can do it a couple of ways, so I'm just going to go to copy this time. Okay, I go here, I click on the paste, and I click paste values, okay, because I only want the numbers, I don't want the formulas. I highlight the accelerations, I click paste, and paste values. Oh, I'm sorry. I need to click here. I think I made a mistake, so I'm going to go back. When you make a mistake, you can always go back with this button. So I highlight the accelerations. I click on copy. I click here. I do paste, paste values, and those are my values. So now I'm ready to graph. I am going to highlight all of my values. I go to insert. I go to scatter. I click on the first one. It looks very, very linear. I'm very happy with that. Okay. But to check, I'm going to right click on this point. I go to add trend line. I click on display equation on chart, display R squared on chart, and close. And look at how wonderful that data is. R squared, which is our correlation constant, which tells us how well it fits our mathematical equation, is 0.9995. And remember, if it's 1, that's a perfect correlation, a perfect fit. So that's very, very good data. Okay, so now I'm ready, of course, to add the titles. So I go to layout, I axis titles, the horizontal axis. Okay, since this is what I'm given, this is going to be the weight force, and that's measured in newtons. Okay. Then I go to axis title, vertical. I'm going to do a rotated title. Okay, so I'm going to highlight those, and that is going to be the acceleration, and that's going to be in meters per second squared. I'm going to highlight the 2. I'm going to go to home, font, make it a superscript. Okay. Then I'm going to go back to layout, chart title above the chart. I'm going to put the dependence of acceleration on applied. Oh, I don't think I typed applied. Okay, let's try that. Applied weight force. Okay. And what I'm going to do, okay, that looks very good. That looks good. Okay. Now what I'm going to do, because I like it to look a little better, and if you put it on a separate sheet, it looks a little better. So I'm going to right click, and if I right click on the chart, I should have a move chart option, and I'm going to make it a new sheet and see how much better that looks. So now I have my graph. And so I hope that this was helpful. It looks like the experiment works very, very well. This is based on someone who submitted their data. They had a few mistakes, but I corrected those. But it looks like the experiment works very well. So I hope that this helps you with your calculations. If it's helpful, let me know, and I'll try to do this for the rest of the experiments where you have graphing and calculations. All right. If you have any questions, just email me.